Hello, my name is Mario Hinojosa, and I will be presenting my extra credit assignment through a screen recording on my iPad. Sorry about that. So I did choose equation 13. F of x equals x squared minus 4 divided by x minus 2, where x can only be 0 to 4. That is my interval, 0 to 4, but x cannot equal 2. Okay, so on the first step, we had to find the limits and continuity analysis, right? So I had to determine and prove the continuity or discontinuity of the function at key points and calculate left-hand and right-hand limit at specified points. Okay, so before that, to find continuity, there is 3 rules up here on the top right, where f of a is defined. The second rule would be the limit as x approaches a of f of x exists, and the limit as x approaches a of f of x equals f of a. Okay, so on continuity, f of 2 is not defined, so therefore the function is not continuous. Okay, so I did look for my limits. Once I worked it out, I noticed that I could cancel out the x minus 2 and then just be left with the limit as x approaches 2 from the left, x plus 2, and it approaches 4. Now on the right, I did the exact same work, canceled out my x minus 2's. The limit as x approaches 2 from the right is also 4, so my limit of x as x approaches 2 is 4. Okay, I did draw out my graph right here, and as you can see, there's a hole on 2, right? So when I plug in 2 to my original function, you are left with 0 over 0, which means it's undefined. Okay, so part 2 is the differentiation step. I was tasked on deriving the first and second derivatives, and I had to identify critical points, inflection points, and discuss the behavior of the function, whether it's increasing, decreasing intervals, and the concavity. Okay, so to derive it, I did have to use the quotient rule. That's f prime of x times g of x minus f of x times g prime of x over g of x squared. Okay, so my f of x is x squared minus 4. My g of x is x minus 2. My f prime of x would be 2x. My g prime of x is just 1. So once you plug everything in, you are left with 2x times x minus 2 minus x squared minus 4 times 1 divided by x minus 2 squared. After simplifying some more, I did multiply. I am left with 2x squared minus 4x minus x squared minus 4 over x minus 2 squared. Simplifying even further, I was left with 2x squared minus 4x minus x squared plus 4. Once I distributed the negative, that's what I was left with. Then I did notice that if you separate the squares, multiply them by together, you are left with x squared minus 4x plus 4 divided by x squared minus 4x plus 4, which gives you just 1. So my f prime of x is 1, meaning that my f double prime of x would just be 0. Okay, now here, this is where I did my work for my critical points. I did have to take the derivative, equal it to 0, then solve for x. But since my derivative of f of x equals 1, there is no critical points. Now inflection points, I had to take the second derivative, equal it to x, find my inflection points, and then using those inflection points, I plug it into the same second derivative and check if the sign changes to see if any part of my intervals increase or decrease. But since there is no inflection points, I wasn't able to do that. Okay, so the function does not have any critical points, nor does it have any inflection points. The function behaves like a straight line that is always increasing, just like how I showed you on this graph right here. Okay, so that is my second step, which is the differentiation. Now for my third step, application of derivatives, I was tasked on solving optimization problems related to the function, and use derivatives to sketch the graph and label key features like maxima, minima, asymptotes, etc. So on the optimization problem, I was confused. I wasn't too sure what I was supposed to solve for. You know what I mean? So I did plug in my original function, and after you derive it and stuff like that, you are just left with x plus 2. So my minimum on my interval is 0, and my minimum on my maximum would be 4. Once you plug it into this function, my f of 0 equals 2, which would be my minimum on my closed interval. When I plug in the 4 to this equation, my f of 4 would give me 6, which would be the maximum on my closed interval. Now, these maximum and minimums can be used in relation to like maximizing profits, minimizing costs, and just optimal value of some quantities. Here is my, the sketch of my graph. F of x is my original function. As you can see, it's just a straight line. Now, I also did graph my derivative, which is just 1. Okay. Now, as you can see here, I did have a hole, and I did include it here, right? X could not equal 2. There is a hole in my line. Since the equation is linear, the maxima and minima will occur at the endpoints of the closed interval. My minima would be 0. I'm lying. My minima would be 2, and my maxima would be 6. I did put a 0 here, and that is incorrect. Now, I do not have a vertical asymptote, nor do I have a horizontal asymptote. And so, so like I said, I wasn't too sure if this part is correct, the optimization problems, but I just did not know what to reference back to. Now, finally, on the integration step, which is the final step, I had to evaluate definite and indefinite integrals of the function where applicable. I had to use integrals to calculate the area under the curve and interpret results in theoretical terms. Okay, so here I did just write again my original function, f of x equals x squared minus 4 divided by x minus 2. Okay, so on my indefinite integral, I just followed the steps like how we did in class. Then you see I can cancel out my x minus 2, so I am left with f of x equals the integral of x plus 2. And once you find the antiderivative, your indefinite integral would be f of x equals x squared divided by 2 plus 2x plus c, since we don't know if there is a number there. Now in my definite integral, I also got, the integral, the antiderivative is also the same, x squared plus 2 plus 2x. Now for the definite integral, we do plug. So we are left with, the integral as 0 approaches 4 of x squared minus 2 plus 2x. Once plugging in, we are left with 4 squared divided by 2 plus 2 times 4 minus 0 squared divided by 2 plus 2 times 0. Now down here, I did break it down some more. 4 squared is 16 divided by 2 leaves me 8. 2 times 4 gives me 8. You add them together, you are left with 16. 0 squared divided by 2 is 0, plus 2 times 0 is 0, so minus 0 would give me 16. Now here in this graph, it's just a rough graph, but this area would be 16. And yes, so that is my extra credit assignment. Thank you for watching, and if there's any mistakes, if you can please just reach back out to me. Thank you.